In this lecture, we will introduce the concept of electric field lines. Electric field lines were introduced by Michael Faraday to understand the concept of electric field better. Though it must be mentioned that the actual meaning that Michael Faraday associated with electric field lines does not hold, but it is a very useful device to visualize electric field. There are four important properties of electric field lines that we will state below. The first property is the following. The electric field lines start on positive charges and end on negative charges. Let's draw a figure to understand this statement better. Consider a charge plus Q. Then the electric field lines will be given by these arrows. Notice how the arrows are pointing away from the positive charge. If we are to draw the field lines for a negative charge, then the field lines will look something like this. A word of caution: you have to be consistent when drawing the electric field lines. Let me elaborate this point a bit more. Suppose plus Q is 1 microcoulomb and you have used 5 lines to depict 1 microcoulomb of charge. Then to represent 2 microcoulomb of charge, we will have to draw 10 electric field lines. You have to be consistent with this. Again, in principle, the number of field lines that one can draw depends on the ability of the person who is drawing the field lines. So you can draw 10, 20 or 40, as many as you like, but kindly be consistent. So once again, to repeat, the electric field lines start on positive charges and end on negative charges. Let's look at the electric field lines for a dipole. Minus Q. They start on positive and end on negative. You can look up your textbook to see the figures for other charge distributions. The second property of the electric field line is the magnitude of the electric field line at any point, the magnitude of the electric field at any point is proportional to the number of field lines per unit cross-sectional area perpendicular to the lines. Let's expand this property. Say we have a charge Q that is positive and the field lines are as shown. Property 2 states that if we have a unit cross-sectional area, so let's say I have a unit square here, the number of field lines passing through this is 2, and at some other point, let us place the same unit cross-sectional area, unit square, and now the number of field lines passing through it is only 1. So property 2 tells us that the electric field at this point in space is stronger as compared to the electric field at this point in space. Let us move on to property number 3. The tangent to the electric field line passing through any point in space gives the direction of the electric field at that point. To illustrate this point a bit more, let's consider the electric field lines for a dipole. Once again, to recall, a dipole is a configuration of equal and opposite charges separated by a distance d. Let's draw the field lines. Property 1, they start on positive, end on negative. Let's say I want to find out what is the electric field at this point in space. Property 3 states, if you draw a tangent to this field line, this is the direction of field at point P1. If I want to find the electric field at point P2, once again I draw a tangent at P2, and this indicates the direction of the electric field at P2. Similarly here, P3, draw a tangent. This will be the electric field at P3. And finally, the fourth property of the electric field line is electric field lines never cross each other. You will never find one electric field line intersecting with another. So let's say this is one electric field line. You will never find another electric field line crossing it. The reason is rather simple, because if I were to draw a tangent at the intersection point, then it would give two different directions at that point, which is not possible. With this, the lecture on electric field lines is complete. I strongly urge the students to look at the electric field line figures that are available in your textbook.